Well. Welcome to the Daily Space Weather here at the Smash News Network, least busted name in news. It's been an interesting couple of days indeed when it comes to solar activity. So thanks for tuning into the Smash News Network, least busted name in news. Welcome to space. We're delighted to see that you've discovered that our channel exists. So there was a massive coronal mass ejection. It was the Shaquille O'Neal solar filament, which we named a couple of days ago. And it's still intact down there. Likelihood of additional coronal mass ejections very high. Likelihood of large solar flares very high. A little closer view of that. We do have a new sunspot as well. We've seen a decline of solar activity overall since yesterday. So despite some significant flares and significant flare potential, basically less sunspots, degrading sunspots, a lower radio flux, and so on. There is a new group rising right up here. It definitely looks like a sunspot. We'll let you know by the end of the video, hopefully, if it is indeed a sunspot or not. So, of course, most of the activity has been showing up down here in the southwestern limb, including multiple M-class flares and indeed an X-class flare. See yesterday's video for that, and if you enjoy the content, make sure that you visit our links like smashomash.com and welcome to the Neo-Renaissance. Again, congratulations on realizing the channel exists. We're frankly surprised that you found the channel, as our channel is so shadow banned that we have trouble finding our own videos. Because it is 2023 after all, so facts are very controversial things. If you like the content and prefer to see it remain publicly visible, free for all to view, and existent, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We're also on Patreon. Please support the channel via clicking our links, visiting our affiliates, and so on. A great merch shop. We'll show you our featured item here in a moment. First, the Hemp Lucid shop. You can find links below the video to that. Not sure what to try? Take the quiz. Improve your life and health, perhaps with some Hemp Lucid products. Don't forget to enter the promo code SMASHOMASH to save some dough on checkout. The promo code SMASHOMASH on checkout, or just shop via the link below the video. Today's featured product is Croissant Earth Society. When will you stop believing NASA's lies? I mean, why is NASA out there trying to convince people that Earth is spherical? Now, pardon the biting sarcasm on the channel. However, these videos are indeed taking place on the internet. An area completely full of cynicism, propaganda, disinformation, and utter nonsense. We don't put that out. However, we've got plenty of products that laugh and stick a finger in the eye of all of that nonsense. So, Croissant Earth is something we've been making fun of for a long time. Earth, it's actually croissant-shaped. And when will you stop believing NASA's lies? Yes, that is extreme sarcasm on that product. If you click the link to the Redbubble shop below the video, you'll find the products in order of best selling. Getting back to space here again, this is the area where the most activity is currently occurring, and you can expect to see the most activity here for the next probably about 18 hours. We'll still have a likelihood of large flares, especially coming from that area, also in the northern hemisphere, but since this is where the flares have been happening, we've got multiple close-ups. These are all 24-hour videos, by the way. And there is our last close-up. Let's take a look at the sun from a holistic perspective, at least the Earth side. And thanks for leaving a comment, Robert LaFollette. Good morning to you as well. So here's the full disk view. We've got a lot of sunspots setting in the west. That raises the likelihood of solar flares to very high. And we do have a little bit of growth and then decay of these sunspots right here. They looked promising yesterday, and now they look like they've shrunken a little bit. We did have a couple new named groups, and I think we've got another group rising up here. You'll see it just rising on the magnetogram. Right there, you can see some brightening happening there. It's looking pretty weak. That might not even be a sunspot. The leading North Pole field there looking kind of weak. And solar activity, again, has been dropping since yesterday. Thanks for leaving a comment. Mr. Bordages, apparently it's pretty cool around Toronto. So check it out. Here's this is Santiaguito in Guatemala. Great aerial view there of the Caliente Dome eruption. And let's do a brief volcano rundown to see what else is erupting. So here's your volcano rundown. Shivaluch is producing a 15,000-foot plume of volcanic ash as it explodes. It's a flight level 150 over Kamchatka. Yasur. Let's see. Small to moderate near-frequent strombolian activity there around Yasur. As it explodes, no indication of the ash plume size. Please don't fly your hang glider over the Yasur caldera. Popocatépetl exploding, flight level 250. It's a 25,000-foot ash plume there over central Mexico. And then Santiaguito, a bunch of stuff going on there. Magma accumulating in the Caliente lava dome. So that could turn into some sort of an avalanche. There's also extrusive activity creating new real estate there down in Guatemala. Santiaguito producing about a 15,000-foot plume of volcanic ash. Fuego in the same nation there, 15,000-foot plume of volcanic ash, flight level 150, flight level 240 over Colombia from Nevado del Ruiz, 24,000-foot ash plume there. Ecuador seeing a 15,000-foot ash plume from Revenador, and we're unable to detect Sabancaya. Let's take a look at seismicity next. There is the 90-day bar graph. We are seeing a slight 7 magnitude earthquake drought here. And let's see what's been shaken. It's been a very calm 24 hours for earthquake activity. So a very low number of quakes, and indeed very small quakes only. So a little bit of activity there in the Caribbean once again. Looks like the largest quake of the past 24 was a 5.4 near Tonga. Again, a very low number of quakes and only small quakes here on a global basis. And let's get back to space. There's the 171 angstroms wavelength from the GOES-R. Another 24-hour video. And again, we've seen a decline in solar activity since yesterday, mainly because of setting sunspots, but also a little bit of degradation of existing sunspot groups. The 10.7 centimeter radial flux now down all the way to 148 solar flux units. We'll see a huge decline in the sunspot number once again here, unless something sudden happens, as we've got a bunch of setting sunspot groups in the west. So there is your 1-year graph of the radial flux represented by the black line and the sunspot number represented by the red line. The blue line is the AP index. That is just a measurement of that's an average of the KP index. It's global, it's Earth's geomagnetism. That's the blue line. And the pink line there is the Wolf number. That is the 30-day smoothed sunspot number average. So again, we're expecting a large decrease in the sunspot number in the next 24 hours. Space Weather Enthusiast dashboard here forecasting some geomagnetic unrest, and we're just about to be in the state of geomagnetic unrest. I believe the next update will be a KP4, and we can expect to see maybe even above a KP6 here. So we could see mid-latitude aurorae once again, because we're expecting the coronal hole high-speed stream that's just starting to arrive now to be pretty strong. It's just a guess, and it is indeed based on the South Pole current sheet and historic performance of the South Pole heliospheric current sheet. Next, Earth magnetic moment from space for the past 4 hours. That's about 12 Earth diameters, about the size of Earth's magnetosphere. Part of the reason why we say the Earth is croissant-shaped, because if you look at the right image there, it's a bit croissant-shaped. That's from the perspective of a solar proton. There is a valid argument to be made that Earth is indeed croissant-shaped, because from the meridional plane view, Earth's magnetic moment from space is indeed shaped like a croissant. Because all of the funniest jokes are the ones that are true. So we'll be keeping an eye on that. By the way, this depicts magnetohydrodynamic pressure. The units there are nanopascals. So since we just saw an uptick in geomagnetic activity here, let's take a look at the geospace delta B for North America. That's changes to Earth's B field, the field that goes through the magnet. as Earth's field struggles to reach static equilibrium with the incoming solar wind. So there's some significant aurora there over north central Canada. I'll let that play through a second time. Again, we're expecting to see a possible KP6 plus. So maybe as high as a KP 6.66, something like that. And we'll also show the global view here for geospace delta B, Earth's magnetic moment from the ground. Just bring that back to play 1 full hour run there. So again, a minor uptick here in Earth's geomagnetism. It's because of a coronal hole high-speed wind. And we're just getting the magnetic field here, which leads the density portion, which leads the high-velocity portion. So we can expect to see those upticks coming in a couple days. We'll tell you more about it when we look at the real-time solar wind. Here's your KP index currently at 2.67. We're expecting this to be up around KP4 when we see the next update, and as high as up around here. The possibility of KP6 plus in the coming days. Here's your real-time solar wind data measured at Lagrangian point 1, the gravitational equilibrium point about 1 million miles away from the Earth, in between the Earth and Sun, where we have things like the SOHO-LASCO and the ACE and Discover spacecraft, which are what these measurements are from. Current conditions are about 14 protons per cubic centimeter for the solar wind density, solar wind speed about 460 kilometers per second. We're expecting to see that solar wind density get a little bit higher than that, maybe as high as about 25 to 30 protons per cubic centimeter. That should be the true density increase preceding the coronal hole high-speed stream. So you can expect to see in the next 12 hours, 12 to 18 hours, you can expect to see the density drop down and the speed to come up to maybe as high as 700 kilometers per second. I'll guess about 630 kilometers per second. That's the forecast for the solar wind in the coming days. Here are your GOES magnetometers. We're seeing some lower highs and lower lows here than in the previous days. We're in a pretty tight range there for a few days. And now a precipitous dip in the GOES magnetometers. Normally we show the 3-day graph. There you go. And a little bit of a divergence there around midnight local time for the GOES 18, which is what the blue M up here represents. Next, the heliospheric current sheet. Again, Earth is in a south pole current sheet, which the last time this came around provided the strongest geomagnetic storm of solar cycle 25 with a coronal mass ejection impact that lasted quite a long time and caused people to see the aurora as far south as Phoenix, Arizona. So that's the heliospheric current sheet. Again, Earth is in a south pole current sheet. I said yesterday, after looking at some of the data, that I expected to see a sunspot possibly rising in the northeastern limb, and we may indeed have that. We do see a little bit of a acceleration there of the North Pole current sheet, an indication that there may be some sunspots rising in the southern hemisphere as well. Here's your line of sight field plot. We showed you the top view ecliptic plane field plot. There's your line of sight field plot. And of course, Earth moving toward the sector boundary crossing for a North Pole current sheet. And here's your line of sight coronal hole plot. South Pole oriented coronal holes here rotating through. And let's bring up some SDO imagery here. We'll show 211 angstroms wavelength. Probably the best wavelength from SDO to view coronal holes. That data is yesterday plus today so far. So all South Pole oriented coronal holes there at mid to low latitudes there on the Earth-facing portion of the solar disk. And let's move to sunspots next. There is the sunspot scenario. We may have one more named group here, but it's looking pretty weak. We'll have to see what happens if we see more activity rising here or not. We'll show you high-res imagery before we get to our meteorology segment. And here we're going to bring up sunspots. So there is your SDO intensity rating. That is yesterday plus today. And we'll zoom in here to show you all the right latitude bands. Again, that's yesterday plus today's data so far. And let's see. It looks like that group evaporated. So just a big dip in the sunspot number coming today, most likely, which might cause many people to clamor, jump into their bunkers, freak out, and claim that they were right the whole time about a grand solar minimum, a truly ridiculous idea. Next, we've got 171 plus 131 angstroms from the GOES-R. Great at showing flare activity, as well as great at showing the lower corona. Some great detail there in the sun's atmosphere for the past 24 hours. And let's move to energetic particles. So we saw a little spike in the proton flux here, as we've seen a number of large flares. Let's see, 3 above an M class in the past 36 hours. And this most recent one here was an M5.4. M5.4. Peak flux was around 7:30 universal time this morning. And we saw relativistic particles show up there only about an hour and a half after that. So those were some fast-moving particles indeed, moving at a significant percentage of light speed. But just a minor spike in the proton flux there associated with this solar flare. An M5.41 this morning. So here's 94 plus 131 angstroms. We'll show some close-ups of those flaring regions. The flaring region. Again, sunspot activity solar activity in general has indeed declined over the past 24 hours. So if you're worried about the sun shutting down, make sure you go move to your bunker today. And just realize that it's going to be popping back up promptly. Here we've swapped out the 94 angstroms with 304 angstroms. That's ionized helium plus ionized iron. The ionized helium is a reddish color, and the ionized iron is a bluish color. Some nuclear fusion happening there, right in front of your face. As the sun jumps up and down and it says, "You know physics better than to think I'm made of a ball of gas." Yeah. For real. So here's a zoom out that same fantastic wavelength. 304 plus 131 angstroms. By the way, that's part of the extreme ultraviolet spectrum. If you're not familiar with the electromagnetic spectrum, we do recommend a high school level of physics understanding for the channel. So we apologize if sometimes some of this stuff is over our viewers' heads. Again, this channel is appropriate for about a high school level of physics. We don't get super in-depth into things on the channel. And, we're trying to appeal to various audiences here. We're trying to appeal to not only people who are new to space weather, but we are also trying to not offend those who know more about space weather, right? So part of the reason why the videos are done the way that they're done is because we don't want to offend Tamitha Skov or Pierre-Marie Robitaille. We do want to offend certain other content creators, though, so hopefully that's been working out. Hopefully if you are an utter hack about space weather, you're watching this quote and getting mad about it. And we hope that your bunker is in fantastic shape and very well stocked. But the sun's not shutting down. Next, this is what's going on overhead over Lehigh Valley. So we like to show a star chart before we show coronagraphs. And this is from skyandtelescope.org. If you want to make your own, put in your location. This is where things are now. The sun just peeking over the horizon. And just a little note about pole stars, right? So people, they get a little bit confused about the Earth's precessional cycle. So there you see Deneb. You can also see Polaris, the current North Pole. And you can see Vega, which for some reason it's at my zenith. I guess I can't put the green box on it, but you can see Vega right there. And what's the relevance of Deneb and Polaris and Vega? Well, they're all pole stars. Because a quick reminder that all rotating objects precess, and over a period of 25,700 years, Earth's axis precesses, making Polaris, Deneb, which is spelled wrong there because reasons, Vega and Alpha Draconis, those are all pole stars, Earth's celestial pole. So when Polaris is a celestial pole, all of the skies in the northern hemisphere go around Polaris. However, at the other end of the cycle, Vega is the closest pole star. And so anyway, just a quick demonstration there. Remember, folks, all rotating objects precess, whether it's a spinning top, a spinning coin, a planet, a star, or even a galaxy. Continuing on to our solar system forecast, here's where things are now. At the moment, Earth is quite lonely on this side of the solar system. Check it out. No planets over here whatsoever. They're all on the opposite side. Let's do a 1-week forecast. Here's where things will be in a week. Hopefully you're not frightened of a populated or an unpopulated solar system. Keep in mind these things are very far apart, and this imagery is not to scale. Let's move to coronagraphs, since we had some major CMEs yesterday, like that one coming out of the east and southeast. That is the Shaquille O'Neal filament. And again, it still has a massive amount of plasma suspended out there. That's only part of it. Most of it remained intact. Also a CME there coming out of the western limb. Are they earthly directed? Let's look at today's imagery first, and then we'll talk about their likely trajectories. So we always like to have a little bit of additional data there. There are today's images, 37 more frames. We'll also look at stereo A, because it's always great to get a little bit of information before you attempt to make a forecast from your weather station. So here is stereo A on the left, which is located right here, and the Soho-Lascaux C3 here on the right, which is located at Lagrangian point 1 that we talked about earlier in the video. So there's the Shack filament, at least part of it, ejecting. And that is looking like it is safely off to the east and south. We don't expect there to be an Earth-directed component of that CME. And then you've got this other CME, which is a little more recent here, happening in the west and southwest. Also not looking like it is earthly directed. Now, it is a little bit early for that, but so far, we do not suspect that will be earthly directed either. So here are some 24-hour videos. That's the GOES R 304 angstroms in the middle, and the Soho-Lascaux C2 in red, Soho-Lascaux C3 in blue. Let's get a little more data here. And thanks for letting us know about your Instagram practices, Mike. Make sure you follow us over on Instagram, by the way. You might be able to enjoy some of this hilarity with us. Instagram.com/Smashomash. So these are 24-hour videos. Again, some great light shows happening there. Those do not appear to be earthly directed coronal mass ejections at the moment. All we've got is the coronal hole high-speed stream, which is just barely starting to hint at its arrival. Let's take a look at filaments. Again, that is the Shack filament down there. And you can see it bounced around a little bit there, but it still remained mostly intact. So that was a pretty good name for that one. By the way, you may want to name this filament up here after some living person. And so you're invited to follow us over on Twitter. Make sure you follow the hashtag, name that filament, the hashtag SpaceWeather and hashtag SpaceWX. Over on Twitter, here's the past 24 hours in GOES R 284 angstroms. So it's a very uncommon wavelength to be seen on the channel. And we figured since we've got so much imagery of the closest star today, that we would include it. That's another 24-hour video if you weren't aware. See that filament eruption and a couple of flares. Next, we'll show the GOES 16 SUVI. This is the past about 2.5 hours. And you can see the aftermath of this most recent coronal mass ejection there. Some of that plasma looked like it's splashing back down toward the surface of the closest star. Yeah, it's got a real surface, by the way. Maybe that's considered blasphemy in the realm of cosmology. Stars have real surfaces, not simulated surfaces. It seems highly likely that they're made of condensed matter, not gaseous plasma. By the way, if you're not familiar with superionized materials, it is something you may want to read about, because superionized materials are not only the future of cosmology, they're also the future of human technology in many people's opinion. Dr. Pierre-Marie Robitaille stated that if humans can harness the power of lattice-confined fusion, that it will change the course of human history. Anyway, here come our bonus features, starting out with charging hazards. So surface charging hazards exist in a minor and likely not a particularly exciting thing there, just some minor surface charging hazards there caused by low-energy electrons on the outside of spacecraft over the eastern Pacific. No big deal. They are minor. And there's the GOES electron flux cratering, just as we forecast, featuring the arrival of the coronal hole high-speed stream. So this is a common thing. We document this all the time for years and years on the channel. The GOES electron flux there cratering. And you can expect this to drop even lower here in the coming days when we see the real portion of the coronal hole high-speed stream, the high-speed portion, that will remain cratered. So this is going to be down here and maybe even down here. So at least the trend is looking right there from NOAA. The green boxes are NOAA's forecast for the electron flux, and the yellow diamonds are the observation. There's the one-year graph to put that in context. That electron flux is measured at the F layer of the ionosphere. Here is that one slice of the upper thermosphere. That's at about 300 kilometers of altitude. The F layer, the bridge between Earth and space, and the vibrational frequency of the very diffuse gas that is present there. And if you're not familiar with looking at this imagery, don't worry. We'll show the anomalygram, which might be a little bit more insightful for you. So there's the anomaly in megahertz from the 30-day median. It does show 10 times greater resolution. It shows anomaly down to the 10th of a megahertz. And you may see this weird area right here. That's the South Atlantic anomaly, the weakest part of Earth's magnetosphere. There's also a weaker spot over here by Africa's equatorial west coast, the South African anomaly, and the South Atlantic anomaly. Anyway, things not looking too funky here at the moment. There's the latest image. That's 11:15 Universal Time ionogram at 11:30 Universal Time anomalygram. Let's bring it back to 11:15. The heck? There's 11:15, and there is 11:15. We'll also show the total electron content, the global view. This is the free electrons from your GPS down to your handset. Your GPS satellite down to your handset. That's about 12,500 miles of free electrons. And we're already seeing this get a little bit jiggy there, a little bit of electrons there out of place. Some nighttime GPS errors are likely, as those free electrons are refracting signals, even around the equator around noontime. Here is just the North American total electron content anomaly from the 10-day average. We'll let that play through a second time. So some high electron contents there off the west coast of Canada. as well as the west coast of the U.S., also Alaska. Here's just the lower 48 view. Let's close out the space weather portion of the video by looking at some high-res imagery. Is it a sunspot rising in the northeast? I want to know. So I'm going to press refresh and then do it again and take a look at this new rising plage. That does not look like a sunspot. So we've got a very weak leading North Pole field there and a South Pole field trailing it. Does not look like a sunspot yet. Again, we can expect a precipitous dip in the sunspot number in the next 24 to 36 hours. At the moment, activity has gone back down, way down. And before we get to meteorology, just a quick reminder to press like, subscribe, share, etc. Don't forget to follow us on Twitter, Instagram, etc. If you're looking for stuff like lifestyle and fitness stuff, follow us on Instagram. There are also playlists on YouTube. We don't only make space weather videos. So check our playlists. You can even find original music on there. Original music videos like Shut Up Fauci. And all kinds of stuff that you won't see anyplace besides on Twitter. Thanks to our new followers over there on Twitter. Congratulations on seeing our tweets. Despite the pathetic, putrid, and disgusting shadow bans on all of these pathetic, ridiculous, nonsensical, disinformation promoting, propaganda promoting, and fact hiding big tech organizations. Big tech organizations. Since 2020, it's not just junkware anymore. It is now officially deathware. Thanks to everybody who follows us on social media and who has not entirely unplugged from the internet. If you have, you're probably not seeing this video, and I don't blame you, because it has only gotten more pathetic in the past 3 years. Next, we're doing some wave chasing here, so I want to see where the world's biggest waves are, and it looks like they're off the coast of Portugal here. So you may see some guys riding 100-foot waves, not so sure, but looks like the largest waves at the moment are 32-footers in the North Atlantic. We do have some big waves in the Southern Ocean also. So almost as big, but not quite. Yes, I am a wave chaser. All right, so here comes meteorology. These are the winds. Like sands through the hourglass of time, these are the surface winds of your lives. At least in the eastern part of the world. Here are your jet streams over here. As far as got some turbulence happening. Some turbulence happening north of Hawaii in the North Pacific. Next, jet streams of the west, shown here. Strong jets over the U.S. at the moment. Also a strong double jet stream over the Atlantic Ocean. Here are the surface winds of the west, surface winds of the central planet. And these are the jet streams of Europe, Africa, and the Middle East. Next, we want to show clouds and fog. It's too dark for the visible satellite, so we use the 3.9 nanometer radiation. Fun fact, we've got some warm temperatures coming to the mid-Atlantic states. We're going to be like 10 degrees Celsius above normal. That is clouds and fog over the Americas. That's the 3.9 nanometer infrared radiation map from the NASA GOES Interactive Weather Satellite Suite, projecting the croissant Earth onto a fake Adobe Photoshop spherical template to trick people into thinking that Earth is spherical and not shaped like the French breakfast pastry. Continuing on to our weather.gov map. There's our weather.gov map, and if your location is lit, click your location, just head to weather.gov. You've got access to the internet, otherwise you wouldn't be seeing this video. Weather.gov, if your location is lit, just click your location. Those are too many weather alerts for us to cover on the video. So here are some forecasts for the lower 48. That's your temperature anomaly forecast for the next 72 hours based on a GFS model in degrees Celsius. So a bunch of warm air there moving from the central U.S. across the Mississippi Valley and into the eastern portion of the country. We'll also show pressure and precipitation for the same model. That's pressure and precipitation on the GFS 72-hour model. I'll say it a third time. There's some ice coming to the Great Lakes states. Some significant icing there, especially for Wisconsin. Next, we'll also show the accumulated positive snow depth change forecast, since a lot of that precipitation will be in the form of snow, especially west of the Mississippi. Anyway, that's your GFS 72-hour total accumulated positive snow depth change in inches. And check out this low. Here's this low that features the world's largest waves. That's Ireland up there in the upper right. Just give that a minute to initialize. It will be some spectacular imagery from windy.com. They've got a great mobile app, by the way. If you haven't downloaded that, perhaps check it out. Keep in mind the windy.com app for this imagery is putting together some data. That's mostly just the visible satellite there. Fantastic imagery of the area generating the planet's largest waves. All right, continuing on to our lightning mapper. Lightning has been very light in the past 10 hours over the U.S. Let's see if we have any terrestrial strikes. Central and South America were a little bit more active for lightning. We've got some lightning there in Western Europe. Looks like some thunderstorms over Germany, which is, by the way, where blitzertung.org is located. Next time you hear thunder, check out lightningmaps.org. You can even forecast thunder and freak people out, making them believe that you're Zeus or Thor or something like that. Or maybe even you can get people to believe that you're Gond. Oh my Gond. Have you convinced the natives that you're Gond? Dear Gond, that would be a crazy thing to do. Anyway, there's the full 50-state view. We're going to focus on the lower 48 view to close this thing out. There is U.S. Doppler radar. That shows vertical motion in the air column. Here is clouds and fog over the U.S. Again, 3.9 nanometer radiation. And here is the 6.19 nanometer radiation showing the water vapor. Looks like clear skies over Arkansas at the moment. Anyway, to close things out, there is your U.S. Doppler radar. This is what you call a weather recap. There is the clouds and fog scenario. And there is the water vapor map. That should clear things up if your Doppler is not clear. Hopefully we made space weather and Earth weather clear. Hopefully you're able to forecast your weather both on Earth and in space. But in the meantime, may that solar wind be at your back. Also, don't forget to visit the links here and here and here.